Guys, welcome back to my channel. Today we're going to be looking at a CXC Pure Mathematics internal assessment from module 3, and without further ado we get right into it. Question 1a says determine the limit of x plus 2 all over 2x cubed minus 8x as x tends towards minus 2. Now, what are the things that we know about limit? This is saying what is happening to the function as x moves towards minus 2. One way of finding the limit of a function is using what we call direct substitution. However, with a rational function, which means a function written as a fraction, we have to check that when we plug this value in, the denominator is not 0, as division by 0 is undefined. Now, if I put minus 2 here, I'm going to end up with minus 16. Of course, if I put minus 2 here, I'm going to end up with positive 16. Now, negative 16 plus 16 is 0, so that can't work. Now, there are different algebraic methods that we can take to address the problem, one being factorization, as it would appear with this one. So I need to factorize this and see what happens. So I'm going to have the limit as x tends towards minus 2. I'm going to have x plus 2 as my numerator all over. In my denominator, I can factor out a 2x. If I take out 2x, I'm going to have x squared minus 4. Good. This is how we call the difference of two squares, and you have to master concepts such as difference of two squares, perfect cube, difference of two cubes if you want to do well in math. Alright, taking this down now, I'm going to have a limit of x plus 2 all over 2x into x plus 2 into x minus 2. Doesn't matter which one I write first, as multiplication is commutative as x tends towards minus 2. Now look at what happens. This takes this out, so I'm left with the limit as x tends towards minus 2 of 1 over 2x into x minus 2. Now I'm not going to have a problem here, so I can make my direct substitution, which means that the limit sign doesn't come back. So I'm going to have 1 over 2x, well, x is minus 2, so 2 times minus 2, bracket, minus 2 minus 2. Alright, here I'm going to have 1 over, this is going to give me minus 4 times minus 4, which is 1 over 16. Now you can write a statement that says therefore, so you'll actually come back to this over here and say therefore, this is equal to 1 over 16. And that's for question 1. Alright, in the meantime, look at question 1b. 1b is referring to what we call differentiation from first principle. And it says, using first principle, differentiate the function f of x. Now, before I get into the whole idea of that, let me start. And of course, the definition of first principle, differentiation from first principle, is where the whole idea of the shortcut of differentiation comes from. So it says that you can have dy dx or you can have f prime of x. So I'm going to have f prime of x is equal to the limit of f of x plus h minus f of x all over h as h tends towards 0, the limit. Alright, let me write this properly. So let me take out the line right here. So I have a limit of this as h tends towards 0. Now you can see the problem here. When I attempt to make a direct substitution, I'm going to have 0 here, which is anything undefined. So you know already I'm going to have to do something to eliminate that problem. Alright, so this becomes the limit. Now f of x plus h simply means that wherever we have x in the function, we're going to replace it with x plus h, so here and here. Alright, let's see what happens. So I'm going to have x plus h all squared plus 5 times x plus h minus 7. All of this would subtract the original function, so I'm going to need a bracket there, which is x squared plus 5x minus 7. And all this goes back over h. Now my knowledge here is going to be very critical. Alright, so to make this simple, I'm going to use up my knowledge of a perfect square. So I'm going to have a limit as h tends to 0. This should be h, yeah. This is a perfect square, so I'm going to have x squared plus 2xh plus 8 squared. We need to know the shortcut for expanding that. Plus 5x plus 5h minus 7. And if I expand this entire bracket, I'm going to end up with minus x squared minus 5x plus 7 all over h. Coming down, I'm going to have a limit as h tends to 0. Now you're going to see some things that can be cancelled out here now. Let's go ahead and cancel them out. So that cancels that. 5x takes out 5x minus 7 takes out 7. So all I have here is really 2xh plus 5h. Do I have anything else? Plus 8 squared. That is what I'm going to have all over h. Now of course I'm going to look to see what I can do here with this h. And of course h is common in the numerator. So one concept that we use very popularly is the concept of factorization. I'm going to have a limit as h tends to 0. Factor out an h. I'm going to have 2x plus 5 plus h all over h, right? H is being eliminated. So all I have to do now is simply input the 0. So I'm going to have 2x plus 5 plus 0, which would imply that f prime of x from first principle would just be 2x plus 5. And of course, being smart, you want to check your answer. So you go up here and you can apply the shortcut method, which is where you bring the power to the front, you subtract 1 from the power. So you end up with 2x plus 5. So I know my answer is correct. Alright, we have to find smart ways of checking our answers. Okay, let me take this out now and move to our next question. So here we go. Alright, my final question, which is part C in this part, says the function f of x is defined by f of x equal x cubed when x is less than or equal to 2 and ax squared when x is greater than 2. This is what you call a piecewise function. Now it says find the limit of f of x as x tends to from the left. From the left, we know it's going to be less than, which is going to be referring to this function. So I'm going to say that the limit of f of x as x tends towards 2 from the left would imply the limit of x cubed as x tends towards 2 from the left, which means I'm simply going to input the 2 here. So I'm going to have 2 cubed, which is going to give me 8. Pretty straightforward. Alright, the value of a for which the function is continuous. Now, what makes a function continuous? This is it. So let me put this as part 2. It's continuous if the limit of f of x as x tends towards 2 from the left is equal to the limit of f of x as x tends towards 2 from the right, which is also going to be equal to f of 2. These are the criteria necessary for the function to be continuous. All of these must be met. Now the limit from the left, we found that already. That was 2. That is also equal to the value for which I'm going to have f of 2, because notice that this says x is less than or equal to 2. So when I'm finding f of 2, I also have to use this part of the function. Good? So I now know that this part is 2, and I know that this part over here is 2. Now from the right, of course, I'm looking for x to be greater than 2. So I'm going to be using this function here. So I'm going to have a times 2 squared. Good? So I'm going to have 2 equal to 4a, which implies that a must be equal to 2 over 4. A is equal to a half. And that's how we deal with that part here. Alright, we move on to module 2 of our internal assessment. Question 2 in module 3. Alright, it says a curve C has equation y equal x squared all over x plus 2. X is not equal to minus 2. I will know why, because if x is minus 2, the function would be undefined. The point P on C has x coordinate 2. Find an equation of a normal to the curve C at point P in the form ax plus by plus c equals 0. Alright, where A, B, and C are integers. First things first. Normal, we have to understand the concept that when we differentiate this curve, dy over dx, it gives us a gradient of a tangent. I'm going to call it mt. But if I want a gradient of a normal, since a normal is perpendicular to the tangent, the gradient of a normal is the negative reciprocal of the gradient of a tangent. So we have to start by finding the gradient of a tangent, which means we're going to have to differentiate this function. Now, of course, because this is a quotient, we're going to be using the quotient rule. And the quotient rule says that dy over dx is equal to v du over dx minus u dv over dx all over v squared. So u is going to be my numerator. So u is going to be equal to x squared and v is going to be equal to x plus 2. Now du over dx, when I differentiate x squared, I'm going to get 2x. And dv over dx, when I differentiate x plus 2, I'm going to get 1. So dy dx is equal to, and of course we can use the cross multiplication here. So this times this. So I'm going to have 2x times x plus 2 minus this direction, 1 times x squared, all over x plus 2 all squared. Let's tidy this up. This is going to give me 2x squared plus 4x minus x squared all over x plus 2 all squared, which is going to give me 2x squared minus x squared is going to give me x squared plus 4x all over x plus 2 all squared. And of course, this is dy dx. Now, what I want is the gradient of the tangent. So in other words, I want the gradient of the normal, but I'm going to start by finding the gradient of the tangent. So I'm going to have mt equal, all I need to do is to take 2 and plug it in here. So when I put 2 in this part in the place of x, I'm going to have 2 squared, which is 4, and 4 times 2, which is 8. I'm going to have 8 over 4 plus, 2 plus 2, that is going to give me 4. 4 squared, 16. So the gradient of the tangent is actually a half, but we don't want the gradient of the tangent. What we want is the gradient of the normal. So let us show you how we deal with that part of it now. So since the two of them are perpendicular, the gradient of a normal, which is going to be mn, is going to be the negative reciprocal, which means it's going to be equal to minus 2. So I have taken care of that part. Let me go over some more so I can get some space. Now it says find the point, find it at P. Okay, how am I going to work that out? To find the equation of a straight line, we need a gradient and a point that it passes through. We have a gradient already, which is minus 2. What about the point? We know that x equal to 2, and we know that y is equal to x squared over x plus 2. So to get the corresponding y coordinate, I'm going to have to plug the 2 coordinate into the y function, which is going to give me 2 squared over 2 plus 2. That is going to give me 4. 2 squared is 4. 2 plus 2 is 4. So I'm going to get 1. So we have the coordinate 2, 1. And we're good to go. So the equation of a straight line now is y minus y1 is equal to the gradient of a normal into x minus x1. So it's going to be y minus 1 equal negative 2 into x minus 2. Y minus 1 equal minus 2x plus 4. Of course, you remember the form that I want it in. Ax plus by plus c equals 0. So I'm going to bring over these terms to make the x positive. So I'm going to have 2x plus y minus 1 minus 4 equal to 0. So we have 2x plus y minus 5 equal to 0. And that would be the equation of my normal. You get it quick, 7 marks. Alright, so the concept is pretty straightforward. Going back, notice we have it in the form. Good to go. Alright, we now move to question 3 in module 3 for pure 1. Alright, it says a curve has equation y equal x over 1 plus x squared. Use calculus to find the coordinate of the turning point of the curve. Alright, how is calculus involved? For a turning point, it's going to be minima, maxima, or point of inflection. But what happens at the turning point? We have a flat line. Alright, so the gradient dy over dx must be 0. So I know that when I differentiate this, which gives me the gradient function, that function will be equal to 0. Now once again, this is a quotient, so I'm going to have to apply the quotient rule. So I'm going to call the numerator x and the denominator v. So v is 1 plus x squared. Now du over dx is going to give me 1, and dv over dx is going to give me 2x. The differential of 1 is 0. Now this implies that dy over dx is going to be equal to, and you know what direction we go first? We go this direction first. Note that this is du, then that direction. So 1 times 1 plus x squared is 1 plus x squared minus, we go the opposite direction now, which is x times 2x, which is 2x squared, all over v squared, which is 1 plus x squared all squared. Alright, now x squared minus 2x squared is going to give me, so I'm going to have 1 minus x squared over 1 plus x squared all squared. So this is my gradient function. The concept is what happens at the turning point, or at the stationary point, or the critical point. They all mean the same thing. The gradient is 0. So this is going to be 0. So I'm going to have 1 minus x squared over 1 plus x squared all squared is going to be equal to 0. Now, of course, I'm going to have to multiply both sides by the denominator here to get rid of the fraction, which means that when I multiply both sides, on the left, this will cancel out. On the right, 0 times anything is 0. So this implies that 1 minus x squared is equal to 0. This is the difference of two squares, as I see it coming up very often. So 1 minus x equals 0, or 1 plus x equal to 0, which implies that x is either going to be 1 or x is equal to negative 1. But these are the x coordinate. I need the corresponding y coordinate. So I'm going to go back to the original function and I'm going to plug in. So y for this x value, y would be, if I put 1 here, I'm going to have 1 over 1 plus 1 square. That's going to give me a half. And if I put negative 1 here, negative 1 over 1 plus 1, negative 1 squared is going to give me negative a half. So I'm going to have y equal to negative a half here. So my turning points are going to be 1 with a positive a half and negative 1 with negative a half. These are my turning points. Alright, so that's part A. Now part B says show that the second derivative is equal to this. So that's where we're going to take it next. So let me just take off all of this right here. Of course, if I'm going to find a second derivative, I have to solve the first derivative. And the first derivative is that dy over dx is equal to 1 minus x squared over 1 plus x squared all squared. Alright, put that there. Once again, I'm going to have to differentiate this, which brings back into consideration the quotient rule, as this is a quotient. So u is equal to 1 minus x squared. V is equal to 1 plus x squared all squared. Now, see how important this is going to be now. Du over dx, which I'm just going to write as du, is negative 2x. But dv brings into consideration the chain rule, as we have this function to a power. So it says I bring the power to the front. I bring back the bracket, which is 1 plus x squared. I subtract 1 from the power, which is going to leave 1 there, and I multiply by the differential of what's in the bracket, which in this case is going to be 2x. Alright, let's put it together now. So d squared y over dx squared is going to be equal to, alright, you know the rule, right? We go this direction first. So I'm going to have negative 2x multiplied by 1 plus x squared all squared minus, alright, and then you're going to have this times this. So I'm going to have 1 minus x squared alright, times 2, open bracket, 1 plus x squared times 2x all over v squared. Now, if you take v, it's raised to the second power already. So if you raise it to the second power again, if you square it again, it's going to be 1 plus x squared to the fourth power, right? Laws of indices, power to power. Now, one of the things that we're looking at here, and we always say the ability to factorize will help you a lot. Notice that the 1 plus x squared is common, so I'm going to take that out. Put that out there. And I'm going to change the nature of the bracket. So here I'm going to have negative 2x open bracket. One of this is gone, so I have 1 plus x squared minus. Alright, so this is gone here. So I'm going to have, in fact, 2 times 2x is going to give me 4x. So I'm going to put the 4x at the front here because multiplication is commutative anyways. And then I have 1 minus x squared there, all over 1 plus x squared to the 4. Now see some laws of indices coming in now. Let me just change the color here. This takes out one of this, leaving me with a power 3. Alright, in this case, if I were to expand this out, let's see what happens. And in fact, I don't need to expand this out because guess what? They factored out at 2x. So let me go ahead and factor out at 2x. Alright, we have to find ways to make the thing easier. If I factor out 2x, I'm going to be left with a negative sign here. That's all I'm going to be left with here. So this negative sign is going to multiply everything inside of this bracket. Alright, so I'm going to have negative 1 minus x squared. If I factor out a 2x from here, all I'm going to be left with here is 2. Alright, so I'm going to have 2 there. So I'm going to have minus 2 times 1, which is minus 2. And minus 2 times x squared is going to give me positive 2x squared. And I'm going to put back everything over 1 plus x squared to the third power this time. So now you have 2x open bracket. Let's see what happens. Negative 1 minus 2, that's negative 3. And negative x squared plus 2x squared, that's positive x squared, all over 1 plus x squared to the third power. Now, of course, we just need to turn it around. So we have 2x into x squared minus 3 all over 1 plus x squared to the third power. Exactly what we wanted, QED. That which has been proven. Alright, so we have done part A and we have done part B. Now part C says determine the nature of the turning point. Since we have found there are different ways of finding the nature of the turning point. Alright, you can test a point to the left and the right in the gradient function and use that, or you can find a second derivative and plug it in. How does it work? We know that if d squared y over dx squared is less than 0, we have maximum turning point, and if d squared y over dx squared is greater than 0, we have a minimum turning point. Now, we're going to have to use the different turning points that we have, which would have been, earlier we said that the turning points were at 1 with a half and negative 1 with negative a half. So we're going to have to test the x values here. So when x equal 1, when x equal negative 1, d squared y over dx squared equal. So let's go over here. Now if I put 1 here, I'm going to have 2 times 1, which is 2, into 1 square minus 3, which is going to give me, alright, let me just put it there. So it's going to be 2 times 1, open bracket, 1 squared minus 3 all over, open bracket, 1 plus 1 squared to the third power. Alright, so I'm going to have negative 2 inside. So this is going to be 2 times negative 2, that's negative 4. So I'm going to have negative 4 over, alright, 2 cubed is 8. So I'm going to have negative 4 over 8, which is negative a half. Good. So right away, I know what 1.5 is going to be. 1.5 is a maximum turning point. Alright, let's try it with negative 1. 2 times negative 1, open bracket, negative. I have to put this in a bracket now because of a sign. All over, open bracket, 1 plus negative 1. squared to the third power. Alright, where we're concerned, this is going to give them at the same sign. So the only thing that is going to be different here is that this is now going to be a positive 4/8. Good. So we can make our conclusion. So at this point, this part here, I can say 1 with a half is what we call, since we got a negative value, it's a maxima, which means maximum turning point. And negative 1 with negative a half is a minima, which means minimum turning point. Alright, we now move on to question 4 and my sample internal assessment of Pier 1 calculus module. It says the figure below shows a metallic cube which is expanding uniform as it is heated. At time t seconds, the length of each side of a cube is 2x centimeter and the volume V is V cubic centimeter. Now, let's start. They say show that the differential of the volume with respect to the length of a side is 24x squared. Now, they didn't have to give you 2x, 2x, 2x. Once it's a cube, all sides have the same length. Now, the volume of a cube is simply equal to L cubed, where L is the length of any one of the sides. Now, one side is 2x, so I'm going to have 2x all cubed. By laws of indices, if you raise a product to a power, each term is going to be raised to the power individually. So 2 to the 3 is 8, x to the 3 is x cubed. That's my volume there. Now I want the rate of change of volume with respect to x. I want dv over dx. Simply we differentiate the volume with respect to x, which is the length of the side. So we bring the power to the front. 3/8 is 24. We subtract 1 from the power, so we have x squared. So it's 24x squared. Alright, that which has been proven. Now it says, given that the volume V cubic centimeter is increasing at a rate of 0.144 centimeter cube or cubic centimeters per second. Let's talk about the volume. That would be dV over dt. Alright, we have to connect it back to the volume and the length of the side. So we have to include dV over dx. Because the length of the side increases, the volume increases. But we are dealing with the rate here with respect to time, which is my third parameter. So now I'm going to have to multiply this by dx over dt. Does it make sense? Yes. Dx cancels dx, we end up with dv over dt. Now dv over dx, we have that. That is equal to 24x squared. Dx over dt, we don't have that. That's what we're trying to find, which is the rate of change of the length of the side. We have this as well, which is 0.144. So 0.144 is equal to 24 times x squared. X is 2 at this moment according to the question, so 2 squared times dx over dt. So I'm going to have 0.144 is equal to 96 dx over dt. So dx over dt is simply going to be, we know we're going to have to divide here, 0.144 over 96. Let me plug that into the calculator. That's 0.0015. And since we're talking about the length of a side, is centimeter per second. Alright, go there. Part 2 says the rate of increase of the total surface area A of the cube in square centimeters per second when x is equal to 2. Now, let me just create some space here and point out some very important pieces of information. Notice that x, which is the length of the side, x is not the length of the side because the length of the side is 2x. X is the constant, so x is the same down here. Now, the total surface area means the area, the sum of the area of all the faces. We call that TSA. Alright, so I just need to find the area of one face, which is 2x times 2x. Multiply that by 6 and I get it. Now 2x times 2x is 4x squared times 6 would give me 24x squared. So the total surface area is actually equal to the rate of change of the volume with respect to the length of a side. Very interesting here. Same concept applied to a circle and same concept applied to a sphere. Now, in this case, since I'm going to be finding the rate, I'm going to have to actually find the increase. So rate of change of the total surface area with respect to x, because that's a connection I have here. I'm going to get 48x. Alright, let me create some space on this side. What they actually want me to find is the rate of change of the total surface area, which means I'm looking at it with respect to the variable time. Alright, so that's my third parameter there being introduced. So I need to find dA over dt. I have a connection between area and length. So I'm going to have dA over dx. And I'm going to have to multiply this to make it look like this now. I'm going to have to multiply by dx over dt. Alright, because if the area is going to change with respect to the length, then of course the length must be changing with respect to time. Alright, let's put in what we know. dA over dx is 48x. And this already, we found it from the previous question. The length is still the same, so it means that the rate of change of length is still the same, which means it was 0.0015. So this becomes 48 times 2 times 0.0015, which of course in this case, what I'm going to end up with is 0.144 square centimeters per second. Very interesting there, right? And that's it. Alright, we're now moving to question 5. Let's get right into it. It says use calculus to find the value of the integral of 2x squared minus 3x to the 4 plus 2x cubed over x squared with respect to x between -1 and 1. Alright, so we have what is called a definite integral here. Okay, let's get right into it. Now the first thing I want to do is to start out by simplifying this expression right here. So you know that whenever we have the expression like this, we can actually split it. Let me put -1 here and put 1 here. I can write this as 2x to the 5 over x squared minus 3x to the 4 over x squared plus 2x cubed over x squared dx, right? Bracket by this. So this boils down, of course, lower boundary is -1 to be the integral between -1 and 1 of, let me catch this right now. So x squared into this is going to be 2x cubed minus x squared into this is going to give me 3x squared, and x squared into this is going to give me a positive 2x integral with respect to x. Alright, so let me take it a step further. So now, since everything is clear here, I can go ahead and integrate, which in this case is pretty straightforward. The rule says that I add 1 to the power and I divide by the new power. So I'm going to have 2x, add 1 to 3, I'm going to get 4, put it back over 4, minus 3x cubed over 3 plus 2x squared over 2. The boundaries are -1 and 1. Alright, and of course this can go down further. I can write this as a half x to the 4 minus x cubed plus x squared between -1 and 1. So all we have to do is plug in the upper boundary and subtract when we plug in the lower boundary. Alright, so I'm going to have a half 1 to the 4 minus 1 cubed plus 1 squared, and I'm going to put in -1. So I'm going to have a half -1 to the 4 minus 1 -1 cubed plus -1 to the second power. All this right here is really calculator work. Alright, so I'm going to plug all that inside of the calculator. In fact, let me bring up the calculator here so we know exactly how to plug that in. Alright, so I'm going to have an open bracket. I'm going inside the bracket now, so I'm going to have a half open bracket 1 to the 4 alright, minus, that's 1 cubed alright, plus 1 squared. And I don't have to put in all this really, because I know 1 squared is 1. Now all this is going to subtract when I put in the second bracket. Now you have to be more careful with negatives because all the negatives need to go inside of the bracket. So here I'm going to have a half 1 close bracket raised to the fourth power, right down there, minus open bracket negative 1 cubed, go down again, and then I'm gonna have plus open bracket negative 1 close bracket square negative 2. So all this really boils down to negative 2. That's your final answer, negative 2 for A. Alright, you can go ahead and look. Alright, to move into question B. It says the integral of x plus 4 all squared between k and 0 is equal to 64/3. Still also a definite integral. Alright, but I simply need to find k. Alright, so what do? I do exactly what it tells me to do. So I have the integral of x plus 4 all squared between k and 0 dx. Don't forget the dx now is equal to 64/3. So what do? This is a linear function. Of course, we can use the shortcut to integrate it. It says that we simply add 1 to the power, so it becomes 3/3 times the differential of a bracket. This only applies to a linear function. In fact, we don't even have to think about the differential of the bracket. It's a coefficient of x, because the gradient of a linear function is a coefficient of x times 1. Alright, between k and 0 is equal to 64/3. So we're going to plug in the upper boundary now, which is 0. So I'm going to have 0 plus 4 to the third power over 3 minus, put in a lower boundary. This is going to be k plus 4 to the third power over 3 is equal to 64/3. Now, because all the functions are over 3, I can ignore the denominator. So I'm going to have 4 cubed, which is 64, minus k plus 4 cubed is equal to 64. Taking over the k plus 4 and taking over the 64, I have 64 minus 64. This goes over as a positive, equal to k plus 4 all cubed. Now this is 0. So I need to get rid of a cube, so I'm going to go with cube root, right? Cube root. So I'm going to have 0 equal to k plus 4, which means that k has to be equal to negative 4. Alright? And that's it for question B. So we'll do exactly what the question tells us to do. Just remember this general rule that whenever you have a linear function and you integrate it, let me ignore the boundaries, alright? With respect to x, it's going to be to the n. It's going to be ax plus b to the n plus 1 over n plus 1 plus c. Alright, to get right into the final question, which is question 6, which says by using the substitution u equals sin x plus cos x, show that the integral of the left hand side here is equal to that. Of course, you notice we don't have any boundaries here. Alright, so we call it the indefinite integral. Alright, let's get right into it. U should be equal to sin x plus cos x. Now, if I'm going to change a function to a u function, it means that I'm going to have to also get rid of dx and get du. But I can't just put du there. I'm going to have to find it. So what do? I'm going to find du over dx, which is equal to the differential of sin x is cos x, and the differential of cos x is negative sin x. So I'm going to have to transpose this thing for dx. We can simply use simple art of cross multiplication. So we can bring dx up and we can bring this down. Alright, so I can say du over cos x minus sin x is simply equal to dx over 1, which is still dx. Right, let's go now. So I'm going to rewrite the function now. I'm going to have sin x minus cos x. I'm going to change the sin x plus cos x to u to the 7th times du over cos x minus sin x, because I'm replacing the dx with a function of u. Now these two things almost look alike, like they could cancel out, but they're not the same. So what I could do is to factor out a negative sign here. So I have negative 1 which makes this negative sine x plus cos x, sorry, multiplied by u to the 7 times du over cos x minus sine x. Now these two are the same. All I have to do is write the cos x first, but by just looking at it, we know it's the same. So I have negative the integral of u to the 7 du. What do? I simply add 1 to the power to integrate and divide by the new power. So it's u to the 8 over 8 plus a constant of integration, which is c. Don't leave that out. But we're not finished, because remember, we don't want it in terms of u, we want it in terms of x. So recall, u was this. So you're going to have negative sine x plus cos x to the 8 plus c over 8. Alright? Which is the same thing as saying negative 1 over 8 bracket sine x plus cos x to the 8 plus c. That which has been proven. Alright. Now the final part, which is part B, find the exact. So they put in boundaries in there now. Alright, but the beauty about this is that you integrated it already. So all I need to do is simply plug in the boundaries. Let me just rub this part, go all the way down to where I need it. Alright, so all I have to say is this would imply, of course, when I take out the plus c, 1/8 sine x plus cos x to the 8, of course. My boundaries are 0 now, and pi over 4. So I simply just need to plug in upper boundary and simply subtract when I plug in lower boundary. Alright. So I'm going to have negative 1/8. Alright, so I'm using up all my brackets here. Upper boundary is pi over 4 sine pi over 4 plus cos pi over 4 to the 8 minus when I put in the lower boundary. But here's the case, because this is negative and I'm going to have a minus here, it becomes positive. 1/8 open bracket sine 0 plus cos 0 all raised to the 8. Just work this out, because you're supposed to know your knowledge asserts. So this is supposed to be negative 1/8. And they say find the exact value, so I can't use that. The sine of pi over 4 is going to give me root 2 over 2. Cos pi over 4 is going to give me root 2 over 2 as well, to the 8 plus 1/8 open bracket sine 0 0 and cos 0 is 1, so I'll have everything to the 8. So I have negative 1/8 now, open bracket, this is 2 of them, so I have 2 root 2 over 2 to the 8 plus 1. Anything 1 raised to the 8 is 1. Alright, fix this out. This is gone. So I'm going to have root 2 to the 8. So I'm going to have negative 1/8 root 2 to the 8. Alright, that's going to give me, well, you know that root 2 times root 2 is 2. And you're going to have 8 at these, which means you have 4 pairs. So you're going to have 2 times 2 times 2 times 2. 2 to is 4, 2 4 is 8, 2 8 16. 16 plus 1. So negative 1 over 8 times 16, that's negative 2 plus 1, which is negative 1. Alright? So that's my final answer. That's my final question.